Assalamu alaikum and hello again. Today we will talk about topic 1.2. It's in page 7, main components of the computer system. As you see, we have these four main parts in the computer system. Input device, which is the purpose of it is to provide the data for processing, and it can be entered by using any input device like keyboard, mouse. And what is data? Data is the raw facts which is to be manipulated and processed. As you see, data has no meaning. Now, after we enter the data using the input device, it is entered to the processor. Processor with the assistant, the main memory, will do something with this data as calculations, comparing, sorting. Sometimes we need also to refer to the storage device to keep this data and to keep these results in some software or program. Now we have, as a human, to see this result. I can see it using output device, which is displaying the result of the processing. It can be done using any output device. Output devices, the main two, like monitor, printer, also the speakers and the data show. Now what is information? Information is the processed data which has been given some meaning. Now data has no meaning. After we do the calculations, we have some answer, we have it as an information. Now storing data and information, also programs not being used at current time, it is stored in the storage devices. Backing stored device, it is reader or recorder. Now the example of storage device is hard disk drive or hard disk. Now the backing storage media is the hardware containing that. Now as you see, hard disk drive, it is backing storage device, but hard disk is backing storage media. We have to know it is different, it is not the same. Now after this,
the processor, also known as the CPU or central processing unit, is a key component in any digital device. You would find at least one processor in a desktop or laptop computer, as well as in a tablet or mobile phone. But processors can also be found in digital watches, microwaves, petrol pumps, and electronic musical instruments. Any digital device has at least one processor, and there are billions of them throughout the world. So, what do?
Although they are very complex components, processors have only two simple roles. They follow instructions and they perform calculations. The instructions come from program code that enters the processor from some form of memory. Program code on a laptop might give instructions to the processor on how to calculate a total from a column of numbers. Program code in a microwave might give instructions to the processor that would result in the clock counting down. In either case, or in any other, the processor follows the instructions laid out in the program code.
As well as following instructions, processors perform calculations. These might involve arithmetic operators, such as plus, minus, divide, and multiply. They might also involve comparisons between two values to see if one is less than, greater than, or equal to the other.
An individual action performed by a processor is usually a very trivial one. A piece of data might be retrieved from memory or placed into memory. Two numbers might be added together, or a signal might be sent to another part of the computer. While these actions are extremely simple, a computer is useful because it can perform a large number of them in a small amount of time. A modern laptop, desktop, phone or tablet can perform billions of individual tasks in a single second.
One way in which the performance of processors is measured is the clock speed. This is the number of tasks that can be performed in each second, and it's measured in hertz. 1 hertz would be one task per second, but processors are of course far more productive than this. 1 kilohertz is 1,000 tasks per second. 1 megahertz is 1,000,000 tasks per second. 1 gigahertz is 1 billion tasks per second. A typical desktop computer might have a clock speed of 3 GHz, meaning 3 billion tasks per second. That computer might have multiple cores, with each core processing at the same time. A quad-core 3 GHz processor could handle up to 12 billion tasks per second.
Processor technology develops very quickly. There's even a term to describe how quickly the technology moves on. Moore's law states that the number of transistors on a processor doubles every year. Since a processor's performance partly depends upon the number of transistors, it could be said that processor power doubles every year. Recently, the rate of increase has slowed a little, but performance continues to increase very quickly.
This continuing increase in performance has two effects, both positive. Firstly, computers can process more data more quickly. This results in enhanced performance in many areas, from more accurate data-driven weather forecasting to higher resolution in games. Secondly, it allows processor technology to become smaller. Due to the higher density of transistors, a smartwatch today can have far more processing power than a desktop computer did a few decades ago.
We can refer for the central processing unit, the CPU, and to find it is a part of the computer which interprets and executes the commands from the computer hardware and software. It is normally part of the computer motherboard. Now, also, as we saw in 1.1, it is the main components, it is discrete and numerous small integrated circuits. All of this is about the CPU. CPU is the microprocessor. Now we refer to it as microprocessor, and also we have microprocessor chips in some other devices. Now it is integrating and it is producing some heat. Because of this we have the fan. Now also we can say this integrated circuit, which is the CPU, it is the heart of the PC. Now we can find some microprocessors in engine management system in the car. Now the CPU also, it is composed of ALU, RAM, and ALU we refer to as arithmetic and logic unit. It is carrying out the calculations and the logic operations and decisions, and the immediate access store, which is the RAM. All of these are in the CPU. Now HDD and SSD, we will find them in chapter 3, but as you know, HDD, it is internal, it is built in our computers, but the solid state drive, it is now internal storage, but we also can find it in our flash memory, stick memory, and the portable hard disks. Now RAM and ROM, as we saw previously, the difference between them, we have also to remember that RAM, it is the volatile, it is the erasable, it is holding the running programs, and also we have to remember that RAM is random access memory. Now for ROM is read-only memory. I have to remember that it is permanent, it is not volatile, we cannot change it, it is sealed by the manufacturer. Now one of the main advantages is that the information stored on ROM is not lost because it is permanent, so it is often referred to as non-volatile. As you see here, it is worth nothing that ROM is not in our computer, so it is very important. Our computer worth nothing if you don't have the ROM. Why? Because it has some coding known as boot file, which is the startup file for our computer. Now it is often referred to as BIOS, basic input output system, which is controlling the input output hardware in our computer. Now we have also the CMOS, complementary metal oxide semiconductor. It has usually battery powered? It is to store the date and time and the system configuration in our computer, and also we have to know it is non-volatile, it is permanent. Now for this we have finished by 1.1 and 1.2 all hardware as internal hardware and the basic components of the hardware in our computer system. Next lesson we will talk about the software, operating system and application software. Thank you.
Computers need to store data. Without the ability to remember, a computer would have no means of accessing instruction number 1 once instruction number 2 was underway. It would not even be able to store instructions 1 or 2, so it would essentially be useless. At various stages during a computer's operation, data needs to be stored, and different types of data require different types of storage. This chapter will examine RAM, ROM, and flash memory.
RAM stands for Random Access Memory, which is also known as main memory or primary storage. RAM is used to store programs that are currently running as well as data that is currently in use. RAM is known as primary storage simply because that's where data goes to first when it leaves the processor. There is also secondary storage, known too as backing storage, which stores programs and data not currently in use.
Programs and data are loaded from secondary storage into RAM, because RAM is much higher speed than secondary storage. Once programs and data are no longer needed in RAM, they can be overwritten. Although RAM is faster than secondary storage, its capacity is usually much smaller. RAM is also volatile, meaning its contents are lost when the computer is shut down.
ROM stands for read-only memory, which is a type of memory whose contents can be read, but not changed or deleted. Accordingly, ROM usually contains data that is never expected to be changed. The main function of ROM is to hold the software needed to start up the computer. When the computer is first turned on, ROM is accessed. It will perform a series of instructions, such as activating the special boot programs that load the operating system onto the hard disk. This allows the computer to start up Windows, Mac OS, or likewise. Since the operating system is not likely to be moved elsewhere on the disk, it is appropriate to store these programs in ROM.
Flash memory is increasingly popular in the form of solid-state drives, or SSDs, and USB pen drives, which are really called USB flash drives. Each bit of data, which is a single 1 or 0, is stored in flash memory using a pair of microscopic transistors. The first transistor either holds a charge or does not hold a charge to represent 1 or 0. The second transistor can read the state of the first transistor. As transistors can be made increasingly smaller, a USB flash drive can contain many billions of them. This means that storage capacity is increasing over time. Flash drives now can typically store many gigabytes of data.
Flash memory is a type of secondary storage. Other than RAM and cache memory, all storage is secondary storage. One of the reasons that flash memory is so popular is that it has no moving parts, which means it is much faster than other secondary storage devices and less likely to wear out or be physically damaged.
Cache memory is accessed more quickly than normal RAM. It is often incorporated directly within the CPU chip. It's used to store program instructions that are often re-referenced and likely to be used continuously.